Welcome, welcome students. Kana, last week we seen the exercise 2.1 how to apply the laws of exponents. Okay, and then we see how to convert the positive exponents to the negative exponents. After that, we see how to simplify the given problems by using a laws of exponents. And the next thing we see how to convert the normal number into a exponent value. Okay, now here the same thing. The seventh question is the number 144 is multiplied with 2 power minus 3, 12 power minus 1, 3 power minus 2. Consecutively, find the final product. That means we want to multiply 144 with all these three exponents. Of that, we get the value as a final exponents or in a normal value. Okay. So, now we want to apply that in the sum. So, the next one is solution. Solution. The first one, what is that? 144 into 2 power minus 3 into 12 power minus 1 into 3 power minus 2. That is the question here. Okay. Now, for this 144, that 144 can be written as 12 power 2. Okay, this 144 can be written as 12 power 2. So, what we get now? Very good. Here we will convert that 144 as 12 power 2 into 2 power minus 3 into 12 power minus 1 into 3 power minus 2. Okay. Now we have two bases as 12. So first combine that one. So 12 power 2 into 12 power minus 1 into 2 power minus 3 into 3 power minus 2. Okay. Now, here it is in a multiplication. So we want to, what we want to do in the exponents? Very good. We want to add the exponents. So 2 plus of minus 1, because in the n value we having a minus 1 into 2 power minus 3 into 3 power minus 2. Now it becomes as 12 power 1 into 2 power minus 3 into 3 power minus 2. Now this 12 can be written as 2 table 6 times, again 2 table 3 times, 3 table 1 time. So 12 can be written as 2 into 3 into 2 power minus 3 into 3 power minus 2. This 2 into 2 can be written as 2 square into 3 into 2 power minus 3 into 3 power minus 2. here there is no value, means it will be considered as a 1. Okay. So now what are the values we have in Kannam? 2 power, we having a 2 same base, that is 2 as a same base. So 2 power 2 into 2 power minus 3 into 3 power 1, because here also we having a same base as a 2 terms. So 3 power 1 into 3 power minus 2. Okay. Then 2 power, here we having a 2 and plus of minus 3, because we have a exponents, loss of exponents. What is the loss of exponents here? A power m into a power n equal to a power m plus n. So we want to apply the law here. So 2 plus of minus 3 into 3 power 1 plus of minus 2, because here also it is a multiply operation. So we want to apply the same law here. So what's the final answer we get here? 2 power 2 and minus 3. Both the signs are different. So we want to subtract that one. So what we get here? 2 and minus 3 means we get the value as minus 1 into 3 power 1 plus of minus 2. Here also the greatest number sign is minus. So the answer becomes 3 power minus 1. So both the powers are in a negative. So convert that as a positive. So what we get here? We want to take a reciprocal of that. So 1 by 2 into 1 by 3. So that in the denominator we having a 2 elements. So we want to multiply that one. So the final answer becomes as 1 by 6. So let us see the next sum. Let us see the next sum. The product of 3 by 4 the whole power minus 4 and minus 2 by 3 the whole power 2 is divided by a number so that the quotient is 3 by 5 the whole power minus 2. Find the number. So here they given that the two exponents, the product of these two exponents is divided by a number. So let a number be x. So the first step is let the number be x. Then what they are given? The first two rational, these two rational numbers, okay, that is exponents. So the product of these two exponents, that means 3 by 4 the whole power minus 4 into minus 2 by 3 the whole power 2 divided by is divided by a number. Here a number is b x, which is equal to, the answer is, so that the quotient is 3 by 5 the whole power minus 2. Now first step is we want to convert the powers to a positive. So first one, it will be converted to a positive by taking a reciprocal of the first number. So 4 by 3 the whole power 4 into Here we having a minus. The power is in a positive only. So split that minus and the remaining rational number. So minus 1 the whole part 2 into 2 by 3 the whole power 2 divided by x is equal to, here also take a reciprocal. So 5 by 3 the whole power 2. Okay. Now split this 4. So what we get? 2 2s are 4. So 2 power 2. So in the place of 4 we want to put a 2 power 2 value. So 2 power 2 by 3 the whole power 4 into minus 1 becomes plus 1 into 2 by 3 the whole power 2 divided by x is equal to 5 by 3 the whole power 2. Okay. Now 2 power 2 fours are 6. Very good. Divided by, 2 fours are 8. Then divided by 3 power, this 4 will comes to 3 also 1 into 2 power 2 divided by 3 power 2. Now we are splitting the powers, that's all. So divided by x is equal to 5 power 2 divided by 3 power 2. The next step is we want to add these powers because the base is same. So add these powers. So what we get now? 2 power 8 plus 2 divided by 3 power 4 plus 2 the whole divided by x is equal to 5 square by 3 square. Now 2 power 8 plus 2. The value of 8 plus 2 was 10. So 2 power 10 divided by 3 power 4 plus 2 value is 6 is equal to, divided by x is equal to 5 power 2 divided by 3 power 2. Now carry over the x to LHS side, RHS side and take this 5 square and 3 square to the LHS side. Okay. So 2 power 10 divided by 3 power 6 is equal to x into 5 power 2 divided by 3 power 2. Now take this fraction to the LHS side. So what we get? It will becomes as a reciprocal here. So 2 power 10 divided by 3 power 6 into 3 power 2 divided by 5 power 2 is equal to x. 3 power 2 is cancelled and 6 minus 2 is 4. So what is the remaining here? 2 power 10 divided by 3 power 4 into 5 power 2 is the value of x in this sum. Okay. See the next sum. Verify using the laws of exponents. First sum is 1 by 9 3 power 3x equal to 3 power 3x minus 2. We want to prove that LHS side and RHS sides of equal. So let us we take a LHS side. Okay. So in a LHS side, what we are having? 1 by 9, 3 power 3x. Okay. Now, what is the value of 9? 9 equal to 3 power 2. So 1 by 3 power 2 into 3 power 3x. So if we taken this to a numerator means it will becomes as 3 power minus 2 into 3 power 3x. So subtract. That is the operation is in a subtraction. So 3 power 3x. Sorry, we will write it in a step itself. Okay. So minus 2 plus 3x. So it can be written as 3 power 3x minus 2. Okay. This is the RHS side. That is equation number, LHS side. That is equation number 1. So what is the RHS side they given? 3 power 3x minus 2. So already they given the value of 2. So first equation, second equation are equal akana. So LHS is equal to RHS. The result is hence we verify. Hence we verify the law of exponents for this sum. Let us see the next sum. See the 10th sum. If x equal to 3 by 2 the whole power 2 into 2 by 3 the whole power minus 4, then find the value of x power minus 2. So for that, first we need to find the value of x. Okay. So let the solution part be x is equal to 3 by 2 the whole power 2 into 2 by 3 the whole power minus 4. Okay. Now, first step is, first we want to convert a negative power to a positive power. So what we get? 3 by 2 the whole power 2 into, it will becomes as a reciprocal. So 3 by 2 the whole power 4. Now here both the bases are same and the powers are different. So base the whole power 2 plus 4 because the operation is in a multiplication. So that we have a first law. We want to apply the first law. So what is the value we get here? 3 by 2 the whole power 6. Okay. Now it is the value of x. Now we want to find the value of x power minus 2. X power minus 2 means nothing. We have a x value. Is it right? From that we want to subtract this power. So minus 2. So what we get now? 6 minus 2 it will be 4. So the value of x power minus 2 is 3 by 2 the whole power 4. The next exercise. Exercise 2.2. expressed in standard form. Okay. Here, first you want to know which is the integral part and which is the decimal part. Here, 0, that is left side of a decimal is called as a integral part. Right side of the decimal is called as a decimal part. Okay. So again I am repeating, left side is called as integral, right side is called as decimal. Okay. Wherever we have a standard form, the first step is we need a one number in the integral part, not a 0. One number in the integral part and the remaining numbers in the decimal part. If we have a zeros in the integral part, we want to omit it. We won't need to write that dot. We need a number from 1 to 9. The numbers from 1 to 9, we need a number. Okay, so let us see here. Here we having a 0.000000067. Okay. So in the last one we have a number, that is a 2-digit number, that is 67, isn't it? After the decimal place, so we are reading that as 67. Now, so we need a integral part as 1. So only first number is 6. From left side, we want to see the number from the left hand side to the right hand side. The first number, which number you are getting, that number is called as the integral part. So here, 6 is the first number. So 6.7. So we want to split this 6 and 7. Okay. So 6.7. The slash means the point will come there. Into 10. This is a standard form. A number into 10. Okay. Here in the power, if we taken from the decimal place, means the power must be in a negative. Okay. This is a decimal place or integral place. Very good. It is a decimal place. So the power must be in a negative. So how many numbers we take? 1 after the decimal. 1, 2, 3, 4, 5, 6, 7 and 8. So the number is 10 power minus 8. Same as here. Here also see from the left hand side, which is the first number here. Very good. 1 is the first number. So 1 must be in a integral part. The remaining numbers we want to write as such as. So 0.2543 000 not have a value, so we leave it. After a decimal place means into 10 power. It is an integral part. So no need to write a negative. It is a positive value. Okay. So count the numbers. After this decimal, after this place, we want to count. 1, 2, 3, 4, 5, 6, 7, 8. So 10 power 8. Again I am repeating, whether we taken a number in the decimal place, the 10 power must be in a negative. If we taken a number in the integral place, we want to be write the 10 power number as in a positive. So be clear in this. Let us see the next sum. Okay. Here the second sum is express the following in usual form. The last sum we seen it as standard form. Now see, they given a standard form. We want to convert that into a usual form. The usual form is nothing but it has a integral part and also a decimal part, or otherwise it contains only the integral part. Okay, whatever it is called as this normal number. Okay, whether it is a decimal number or it is a whole number or it is a natural number, whatever the number it is, whether we write it in a normal number is called as a usual form. Okay, now 5.23 into 10 power 4. See here, it is in a positive. Okay, be clear in this. It is in a positive. Positive means where we want to add the digits. Very good. We want to write it in a right hand side. We want to add the numbers in a right hand side. Okay. So let us see here. How many digits we have in integral part? Only 1. After that we have a 2 decimal places. Isn't right? So 10 power 4 means what? How many zeros we have in 10 power 4? Whatever the number it is, that number of zeros we have in this one. Okay. So 1, and here we have a number as 4. That means we have a zeros as 4. So 1, 2, 3, 4 zeros. Okay. Now multiply this one. What we get? 5, 2, 3, 1, 0, 0, 0 and 0. Now how many digits after we want to put a decimal? 2 digits after we want to put a decimal. Now it becomes cancelled, because after a decimal if we have a 0 means it has no value. So we want to be strike out that one. So what is the remaining here? 5, 2, 3, 0, 0. This is the answer for the usual form of the given 5.23 into 10 power 4. Okay. Now let us see the B sum. 2.05 into 10 power minus 3. Okay, so listen here. The power is in a negative. That means where we want to add the digits? In the left hand side. If the power is in a negative, we want to add the numbers in the left hand side. If the power is in a positive, we want to add the number in a very good right hand side. So now we want to add the number in a left hand side. Okay. So first step we want to write the number as such as. Okay. So 2.05 into 10 power minus 3. The first step is wherever we have a negative power, we want to convert that into a positive power. That means, very good, we want to take a reciprocal. So 1 by 10 power 3. So what is the value of 10 power 3? 1000. So 2.05 into 1 by 1, 2, 3 zeros. That means it is called as a 1000. If we divide our number by using 1000, we have how many zeros? 1, 2, 3. That means we want to put a decimal before, that is from the left hand side we want to count a 3 digits and we want to put a decimal place. So already we have a number as 5, 0 is in a decimal itself. And in the integral part we have only one number. Okay, so 1 we taken here. What about the remaining 2? We take it as a 0. Okay, so 0.00205 is the answer here. Okay, the one more step is having here, that is this one is one method and another method we are having. What does that means? If we have a -3, you want to add a 3 zeros in front of it. Okay, so 2.05 into 10 power -3, isn't right? So how many, now what is the number they given in a power? 3. Very good. So what we want to do here? We want to write the number as in a reverse. 5, 0, 2. Write the given number as such as. Okay. Now 10 power -3. That means we want to add 3 zeros. So 1, 2, 3. Okay. So we put in a 3 zeros here. Now, what is the next thing we want to do? After this decimal place, we want to take a 3 digits. So 1, 2, 3. So 0.00205. Within a single step, we are able to write the answer here. Okay. So let us rewrite the C sum by using the simplest form. Okay. So 2 into 10 power -5. Here there is no any other number. They given only one number as 2 and the other one as 10 power -5. Okay. So how we write this one? -5 means what I said. We want to add a 5 zeros in left hand side. Isn't right? So 1, 2, 3, 4, 5 zeros and then write this 2. Now what I said, from the integral part we want to count as 5 digits. So 1, 2, 3, 4, 5. So put a decimal place over here. So the sum is over. Within a single step you are able to write this answer. Okay. So let us see the next third sum.